Welcome to the Hughes Communications Lab of the University of Maryland at College Park. I'm Alejandra Mercado. I'm Associate Director for the Masters in Telecommunications program at the University of Maryland at College Park. I'm also an instructor, a mentor, an administrator, and a lab coach. The Hughes Lab provides hands-on experience where students learn to work with the EDIS B210 software-defined radio, as well as the GNU Radio Companion, which is a front end to the GNU Radio libraries for digital communications and signal processing.
Hi, my name is Alejandra Mercado, and welcome to our virtual open house. I'm here to talk to you a little bit about the ENTS Wireless Communications Lab, which is equipped with software-defined radios that students use to build custom transceivers. So the lab is equipped with the EDIS B210 USRP. The radio supports up to 56 megahertz of real-time bandwidth, and it can work anywhere from 70 megahertz up to 6 gigahertz. But when we're working wirelessly, we just work in the ISM band. Some of our applications and some of our labs, we use a coax cable to connect the radios, and other times we use antennas wirelessly. Each radio is equipped with a Spartan 6 FPGA, and the RF front end is an AD9361. And each radio has 2x2 MIMO capacity. Depending on the type of lab, sometimes we provide a universal timing, and for that we use the EDIS octoclock. Each radio standalone would achieve a reference accuracy of 75 ppm, parts per million. But when you connect all of the radios to the octoclock, you get 75 ppb, parts per billion. Now, if we, in addition, had GPS connection, you could go down to 1 part per billion, but we don't have the GPS. So when part of the lab is synchronization, then we disconnect the octoclock, and when we're doing other problems, we connect the octoclock, to sort of isolate whatever it is that we're trying to solve. Each station has a mini PC, a NUC 7i, Intel NUC 7i mini PC, and that holds the USRP hardware driver, the UHD, and that's an open source driver providing the API for like GNU Radio Companion, for C or C++, Python, and MATLAB. But in our lab, we use the GNU Radio Companion typically. So GNU Radio is the software that handles the radio drivers and provides the RF front end and the signal processing blocks to program the software-defined radios. So our students, they develop and they test, and they run signal processing algorithms that, modulation, demodulation, pulse shaping, synchronization, equalization. I mean, all different, depending on the lab, we'll do different things. For example, in our OFDM class, our students implement an OFDM transceiver pair. And that includes like the multiplexing and the cyclic prefix and the PAPR reduction and the equalization. All of it is implemented. And the final project deliverable is you should be able to transmit a file from one of the lab stations to the other lab station over a wireless channel using OFDM. And I haven't yet graded my class's OFDM projects, but we'll see how that went this semester. Now, in addition, our program supports students engaging in extracurricular activities. For example, the 5G protocol stack development group. This is a platform for students to work on open source code base for LTE and 5G software-defined radios. So our 5G team started in the fall of 2017 with Darshan Joshi, who spearheaded an effort to run SRS LTE. They wrote a proposal and got funding for the software-defined radios for their group for the front end. They implemented 4G LTE software suite, and they built an end-to-end software radio link between 2 laptops at that time, like going through the radios in 2 laptops. And the package included the LTE UE, the LTE eNode B, the core network, everything was implemented there. And they pulled the software from GitHub and ran it on laptops. In those days, it was on Ubuntu 16.04. So the first team just focused on getting release 8 of LTE to work. Like I told them at the time, getting that first bit across is the hard thing. But once they got that first bit across, they kept working towards enhancing it. By early 2018, they switched over to open air interface because it was more active. And they added the Python bindings and GUI on the code base that they had. And they managed to create a video call between two laptops. Now, Darshan and his team graduated, and so the team was taken over by Sharan Arukula in 2018, and they worked on implementing LTE release 10. They bought a Nexus 5 and a OnePlus 3, 2 UEs, and they programmed the SIM cards and everything. So they actually made a video call from one cell phone to the laptop, to the radio, to the other radio, to that laptop, to the other cell phone. And they achieved data rates that were like 16 or 17 megabits per second in the downlink, and uplink it was like 6 to 7 megabits per second. And they had migrated to 18.04. So right now they're working on integrating an integrated system of LTE and Wi-Fi. That's what the team is going through now. And as the older students graduate and the new students come in, they're always recruiting new members. And it's really helpful to have this on your resume. I mean, besides learning an enormous amount, employers like to see this on your resume because it's been a really successful program. I'm going to leave the links for the 5G group and for a YouTube video of the 5G group in the chat space for you to look over. And I hope you're interested in our lab, and thank you for joining us today.
Here at the Masters in Telecommunications program, we strongly believe that the best student experience involves hands-on labs and projects to equip our graduates to excel in the workplace. One of the things that attracts students to our program is that we are very industry focused. We keep a constant tab on the skills that hiring agents want, and we make sure that we offer courses and labs that provide these skills.